everyone, this is Kruti Jai Pancholi, Assistant Professor in LJ Institute of Engineering and Technology in Department of Electronics and Communication. This video is about subject Analog and Digital Communication Systems. Unit is Introduction to Communication System. In this video, you will learn about energy signal, Parseval's energy and power theorem, and Rayleigh's energy theorem. Very fast, what is the meaning of the signal? So, the signal term that is very commonly used in the communication. The signal is also described as the function of a one or more independent variable. It is the physical quantity. It can vary with the independent as well as the dependent variables. So you can say the definition of the signal, that is a physical quantity which contains some information and which is the function of one or more independent variables or the dependent variables. It can be the one-dimensional or the multi-dimension. There are the different types of the signals. That may be the signal continuous time or the discrete time, then the continuous valued or discrete valued, periodic signal, non-periodic signal, deterministic or the random signal, even or odd signal, energy signals or the power signals. In this video, we want to learn about what is the energy signal, power signal. Very fast, energy and the power. Simply, if we'll ask anyone what is energy, energy is the work, and power, it's a work per time. Work mean what? The force you applied and the displacement. Therefore, the power is the work per time. So, according to the kinetic energy is given by Ke is equal to 1/2 mv square. The electrical signal, in that the instantaneous power of the voltage across the resistance R and the energy that can be defined as Pt is equal to Vt into It. What is the It? It is again the Vt upon R. So is equal to 1 upon R into V square T. Similarly, we can write the equation for the energy, normalized energy, is equal to the minus infinity to infinity 1 upon R V square T dt. Therefore, in the signal processing, the total energy of the signal xt is defined as Et is equal to limit L tends to infinity integration minus L to L xt square dt is equal to minus infinity to infinity modulus of xt square dt. This can be the modulus can be applied for the complex signals. So, En in the digital processing for the nth coefficient, it is limit n tends to 0, sigma n equal to minus n to n xn square is equal to sigma n equal tends to minus infinity to infinity modulus of xn square. So, where the modulus of xt denotes the magnitude of the xt, it is necessary to get a scalar quantity for the complex signal because the magnitude of the complex number is defined as if a plus jb modulus, it is the magnitude is square root of a square plus b square. So, energy of a signal is defined as the sum of the square of the magnitude. So, therefore, the average power of the signal is defined as Pt is equal to limit L tends to infinity 1 upon 2L, that's the total period of the signal, minus L to L xt square modulus of xt square dt is equal to limit L tends to infinity Et upon 2L. So therefore the energy that or signal can be categorized into the two types, energy signal and the power signal. Now what is the energy signal? Energy signal has a finite energy. It is between the 0 to infinity. Energy signals have a values only in the limited time duration. For example, a signal having only the 1 square pulse is an energy signal. A signal that can decay exponentially has a finite energy, so it can be the energy signal. And for this, the power of the energy signal is 0 because of dividing the finite energy by the infinite time or the length. Power signal. The energy signal, that is the finite. Power signal is not limited in the time. It always exists from the beginning to end and it never ends. Suppose the sine wave in infinite length is a power signal. Since the energy of the power signal is infinite, so it has no meaning to us. Thus, we use the power, that is the energy for given time for the power signal, because the power of a power signal is finite and the value of the power is also between 0 to infinity. So now here the equation for the energy signal and the power signal. So therefore the energy for a real time signal is E is equal to minus infinity to infinity x square t dt. Now if the xt signal is a complex, then we need to take the modulus of that. So E is equal to minus infinity to infinity modulus of xt whole square dt. Now what is this modulus of xt square? It is the xt multiply with the complex conjugate of xt. So what it indicates? It indicates that the area under this x square t curve, that is the x square t, and it is the value of t is between minus infinity to infinity, and always this gives us the answer that is the positive. So it is about, this is the thing that we need to remember while we need to solve the example about the energy signal. This equation that is of the real time, a real time signal, a real signal, it is the complex signal. To get for the positive part, we are taking the square of this. And what is this xt modulus of square? It's a xt multiplication with the complex conjugate of xt. Similarly, for the power signal. Now as you know that the signal that can be the periodic signal can be the aperiodic also. So for the periodic signal with a period t0, we can find out the power. It is equal to 1 upon t0 minus t0 by 2 to t0 by 2 x square t dt. Again this is for the real signals. Now for the complex periodic signal xt, the normalized power is what? So it is the modulus of this x square t. So it is p is equal to 1 upon t0 minus t0 by 2 to t0 by 2 x square t dt. So these two energy and the power equations we have to consider. Now based on that, the theorems that are defined. One is the Parseval's power theorem, Parseval's energy theorem, and Rayleigh's energy theorem. Very first, Parseval's power theorem. Parseval's power theorem that is used for calculating the average power P of a periodic signal. Now you know that whenever we want to do the analysis of the periodic signal, we need to go for the Fourier series. So Fourier series coefficients we need to find out. So the Parseval's theorem states that the total average power of a periodic signal is equal to the sum of the average power of the individual Fourier coefficients, that is the Cn. So average power of xt signal is equal to power of C1 plus power of C2 up to the power of Cn. So the average power of a periodic signal is the summation of the some average power of the individual Fourier coefficient. So we can see that it is total average power is equal to P is equal to sigma n equal to minus infinity to infinity modulus of Cn square. Now, Parseval's energy theorem. Now, what is the requirement of this Parseval's energy theorem? You know that the sometime the signals is represented in the time domain and sometime the signals are represented in the frequency domain. Now, while the signals are represented in the time domain, and if the signal that is the very complex, then it is mandatory to convert that frequency domain time domain signal into the frequency domain. So, whenever we want to calculate the energy resides in the signal, so at that time we can go for the Parseval's energy theorem. And if the signal is complex, then we can convert the time domain representation into the frequency domain. So if the signal is represented in the frequency domain, then and then we can find out the energy. And if the signal is represented in the time domain, and then we can find out the energy using the Parseval's energy theorem. So Parseval's energy theorem that states that Eg is equal to minus infinity to infinity modulus of gt square dt. It is the equation of the E that you know. Now in the Fourier transform of this is equal to 1 upon 2 pi minus infinity to infinity modulus of j omega whole square d omega. Now what I need to do? It is modulus of gt square. Now as I have discussed, what is the modulus of gt square? This modulus of the gt square, that is modulus of gt square is the multiplication of gt with the complex conjugate of gt. Now what is the gt? The gt is equal to 1 upon 2 pi minus infinity to infinity g omega e raised to j omega t d omega. Now if I'll take the complex conjugate of this gt, then it is g star t. It is equal to 1 upon 2 pi minus infinity to infinity. The complex conjugate of g omega is again this g star omega is e raised to j omega t. Complex conjugate of that is e raised to t d omega. So putting this equation's value in this, it is minus infinity to infinity. We'll take this gt as it was and putting the g star t value, complex conjugate of gt, it is 1 upon 2 pi minus infinity to infinity g star omega e raised to minus j omega t d omega, and this dt is there. So this is the dt. Now 1 upon 2 pi will take outside of this integration. So it is minus infinity to infinity. I'll again take this g star omega out and I will put again the one integration. In that it is another integration of minus infinity to infinity gt gt e raised to minus j omega t d omega. So it is equal to 1 upon 2 pi minus infinity to infinity. This is the g star omega. But now what is this? It is what? Minus infinity to infinity gt e raised to minus j omega t dt. But now what is this? So we know that okay, we can put this value okay over here, then it is the g star omega and it is nothing but the g omega. So it is the g omega g star omega d omega. It is equal to 1 upon 2 pi minus infinity to infinity g omega into the g star omega, that is the complex conjugate of g omega. It is modulus of g omega square d omega. So whenever you want to solve the example related to the Parseval's energy theorem, or if you want to find out the energy resides with the any signal, then we can go for this formula. So you have to keep in mind again, you have learned all this thing in the subject signals and systems. In the next class, we will learn about how to solve the examples based on the Parseval's theorem as well as the Rayleigh theorem. So this is the last part of the video. Thank you very much everyone.